such that the PNP is in saturation. Okay, for PNP transistor, VB saturation value is minus 0.8. So if we apply the KVL in this loop, that is 0 minus VEB sat minus IBR plus 5 equals to 0. So R is nothing but 5 minus 0.8 divided by IB, which is 4.2 divided by IB. Here IC is given as 2 amps, beta is given as 10. We know in saturation IC is nothing but a beta IB. So IB is nothing but 0.2 amps. So if we substitute 4.2 divided by 0.2, which is nothing but 21 ohms, hence option A is correct. There is no diffusion current in the intrinsic semiconductor. That is assertion. It comes to the reason. Mobile charge carriers are uniformly distributed on the semiconductor. There is intrinsic semiconductor. See, both the statements are correct, and the reason is the proper explanation for the assertion, because the diffusion current in any semiconductor depends upon the concentration gradient. While it comes to the intrinsic semiconductor, the carrier concentration is uniformly distributed throughout its region. Hence, there is no diffusion current because the gradient of charge is going to be 0. Hence, option A is correct. Drain current of an NMOS transistor, if K equals to 125 microamp per whole square, Vt minus 2 volts, lambda equals to 0, VGS equals to 0, VDS is equals to 6 volts. Here, VGS is greater than Vt because 0 is greater than minus 2. Hence, the NMOS transistor is going to be in on state. After that, we have to decide whether it is in saturation region or triode region. That is to be done by VGS minus Vt is nothing but 2 volts. Here VDS is 6 volts. 6 is greater than 2 volts. Hence, the NMOS transistor is going to be in NMOS is in saturation region. For an NMOS transistor which is in saturation region is written as K of K VGS minus Vt whole square. So 1 by 2, 125 into 10 power minus 6, this is 2 whole square, hence 250 into 10 power minus 6. Sorry, this is not there. ID is proportional to K into VGS minus Vt. So it is going to be 500 into 10, that is 0.5 milliamps, which is option B is correct. Across the 4-volt bias diode is 0.7 volts at 300 degrees Kelvin. The voltage changes by 1.88 millivolts per degree centigrade. The combination should have a rated voltage of, this is minus because the diode temperature coefficient is negative with respect to diode voltage. The combination should have a rated voltage of 10 volts. The temperature coefficient required for Zener diode at room temperature is, see, the overall combination is going to have a 10 volts, means the Zener voltage is going to be 9.3 volts because the voltage across the diode is going to be 0.7. We know that the diode, normal diode is having a negative temperature coefficient, that is minus 1.88 millivolts per degree centigrade. In order to compensate that one, the Zener diode must have a positive temperature coefficient which is equals to plus 1.88 millivolts per degree centigrade. So here Vz is 9.3 volts. So it has to increase by 1.88 millivolts per degree centigrade. That is 1.88 into 10 power minus 3 divided by 9.3 into 100. This is equals to 0.020% per degree centigrade rise in temperature. That is option A is correct.
Capacitor made using p-type substrate is in the accumulation mode. The dominant charge in the channel is due to the presence of. Here, if we take a MOS capacitor, first one is metal oxide semiconductor. Okay, here the semiconductor is p-type. Accumulation mode means all the holes are occupied, means negative potential is applied to the p-type substrate MOS capacitor. So if we apply this one at the interface of the oxide, we will get all the holes are accumulated here. Here all the electrons are accumulated here. This is nothing but a channel region where holes are present. That is option A is correct.
Circuit shown below, the relationship between the reference current as well as the I1. So the circuit which is shown in the figure is nothing but a current mirror. So I reference is nothing but 2IB, because both having this current is nothing but this current, this is nothing but I1 itself. So I reference is equals to 2IB plus I1. So we have to express IB in terms of I1, because the equation should contain only I reference as well as the I1. So IB is nothing but I1 by beta. So I reference is nothing but 2I1 by beta plus I1. So if we take I1 as a common, 1 plus 2 by beta is the answer. So option B is correct. This is I1.